I'm Bruno Duplessis. I'm an associate professor at Mid-Paris PSL Armines. I work in a research team called Demand-Side Management, and we develop a modeling approach for building energy systems. So I'm pleased to introduce you today the work done in the part dedicated to the collection of data about technologies and measures, and as well as energy demand and impact assessment. So the aims of this part was to provide a taxonomy of all existing and emerging technologies and measures. So by technology, we mean systems that supply cooling, direct cooling. And by measures, we means all the means that aim at mitigating the cooling needs in the buildings. So there are active and passive measures as well as users' behavior. So the idea is to collect information and then to select data that will be implemented further in the different CoolLIFE tools. In the same part, we also investigate the current and future energy demand for space cooling, as well as social and economic impact of these technologies and measures. The work is partly still ongoing, but there will be public deliverables that will be available in the coming weeks or months. Next slide, please. So we start by screening the literature about technologies, and with no surprise, we of course highlight that conventional vapor compression system represents nearly 99% of Europe's space cooling demand. There are historical reasons for that success. There are scalability, the use of working fluids that are suitable with the different applications. They are quite high efficient with a seasonal performance factor between 3 and 6, depending on the systems, the cold source, and also the climate. And they can be installed quite easily into the buildings. Their efficiency are expected to increase again, even if there are some technical challenges that are coming due to F regulations, regulation that will increase the requirements for the working fluids, but there are non-blocking challenges. So usually we classify the systems into categories, whether they are dedicated to the cooling of rooms or centralized air systems. And also we can highlight that a large part of those systems, especially for the room air conditioners, are also sold as reversible heat pumps nowadays. And so they are also supplying heating as well as cooling in the same with the same system. Yeah. We also screen the literature in order to identify potential alternative technologies. So you have here the picture of that taxonomy. There are various physical principles that can be used in order to supply cooling. Nevertheless, most of these technologies are still in the emerging phase. Lucas has showed the figures that have been provided in the frame of that work. And yes, for the next decade, there is no strong competitor for the conventional systems. We do the same work from the measures, identifications. So again, we suggest a taxonomy of that measures, both passive and passive measures, as well as the solution that can be implemented directly by the user in order to mitigate the cooling needs. With the same methodology, based on the screening of the literature and the interview of experts in that domain. What we can say is that for measures, most of them are on the way to the market. That means that there are ready to be integrated into the building. Of course, there are some barriers for part of them, the cost, or the suitability, the adequacy with some buildings, especially for the existing buildings. So that's why we go further in the investigation in order to specify the suitability of these measures with the different targets, the different buildings. So, next slide, please. We process selection procedure in 3 steps in order to try to specify the adequacy and of these measures and technology with the different buildings and targets, with the aim to be able to propose a list of a reduced number of these technologies and measures to be included in the CoolLIFE tools. So the selection process is based on a multi-criteria analysis. There are several criteria that have been assessed, environmental and economic impacts, factors, for instance, as well as technology, regulatory characteristics. Then we check the adequacy of this technology and measure with the residential and non-residential buildings in order to select a reduced list of solutions. And we push the investigation with a cost-benefit analysis of these solutions in order to quantify better the direct and indirect benefits and impacts. So for the cost-benefit analysis, the aim was to specify the positive and negative impacts. So we are, the internal cost of the systems, the CapEx, the OpEx, of course, but there are indirect costs. The reduction of the thermal discomfort, which is the first aim of these systems, but you have also externalities, the greenhouse gas emissions, for instance, or the pollution or noise, as well as the heat release from that system in the environment. So in order to compare these systems, conventional systems as well as measures, we implement these systems in a modeling approach. Yes, next slide, please. In a dedicated urban modeling energy, in an urban modeling energy modeling platform that aims at modeling the energy system's performance in one hand, as well as the impact of the measures, whether they are active or passive measures, in order to quantify the energy demand and the final energy consumptions. And in the same, in parallel, we also quantify the propagation of noise due to the external units of split system, for instance, or VRF, as well as the impact on the environment, and the impact of the environment on the energy demand through the increase of the urban heat island effect. We did this work for different types of urban districts in order to take into account the diversity of the urban urban environment and 3 relative European climates. So at the end, we we assessed the different direct and indirect impact and cost, and we ranked the selected technologies in measures according to the urban context. So we have here a sample of the result. There are plenty of results in the variable that show that depending on the situations, the targets, or the climate, and as well the urban environment, the ranking of the most suitable technologies change. Last part of the job was to assess the impact assessment. Of technologies and space cooling technologies and users, which are deployed now and that can be deployed in the next decade. And different KPIs are assessed, so different scenarios for the current business as usual scenario, and two other scenarios show perspectives for the future. So different value are assessed, energy savings, the cost associated between users, and the impact on environment and certain benefits. So these scenarios, next slide please, these scenarios differ by the distribution of the technology as well as their the trends in their efficiency increase. And for passive users also, the different scenarios differ by the adoption, the different adoption of the measures that can mitigate the space cooling grids, as well as the impact that the user can play for mitigating these needs. So all these parameters are integrated in a modeling tool. Next slide, please. Developed by TOE in order to quantify the useful energy demand within these three scenarios. Then we introduce the technology features, distributions, and efficiency in order to quantify energy demand and at the end, direct impact of space cooling technologies and measures. And societal benefits and co-benefits are assessed in parallel with the MICA tool, which is a tool that has been developed for specifically addressing these other impacts. So all the results will be in the deliverable that are still in being writing now and revising for a part, and there will be so two deliverables. This next slide that will be available in the coming months. So dedicated for each part of that work, the taxonomy of the space cooling technologies and measures, energy demand assessment, as well as impact assessment. So thank you for your attention. If you have some question, you can write it in the chat. Answer that, and I let the floor to my colleague.
Thank you, Bruno. Are there any questions for Bruno that maybe you would like to address now? So we have one actually, and I guess it's addressed to Bruno. Otherwise, if someone else would like to reply, please feel free. And the question is, what are the climate scenarios and models considered in this study?
So for the cost-benefit analysis, we did not use climate scenarios specifically, but different climate for Europe, which are used by the standards which specify the energy performance of heat pumps and cooling systems. And what was the second part of the question? Yes, so the models that we use are yes. Maybe I can. I will send some detailed information, and we will not go into the detail, but there are urban energy modeling that we currently use in our labs in order to model the energy demand through bottom-up approaches at the building level.
Okay, thank you, Bruno.